Hi, hello friends. Welcome to T Academy. In this video, I'm going to discuss the previous Assistant Engineer Electrical paper questions, and this is a practice test for you. Please watch the video completely and don't skip the video. If you know the answers, also just listen to that video questions and try to answer the questions. Okay, so please watch the video till the end. Don't skip the video. Right. So we'll start the question here. So these questions I have taken in the standard of Assistant Engineer Electrical. It is not too tough. There is not too easy. Okay. So let's start the question here. First question here. The first question I have taken here from the networks. The first question here it is. Okay, let me take correct here, right? Okay. An AC source of 200 volts RMS supplies active power of 600 watts and a reactive power of 800 VAR. So this is a VAR. The RMS current drawn from the source is. Okay. So here we need to find the RMS value of the current source. The exact answer will be for this question is 5 amperes. So I'll give the hint here. So first you will take the P is nothing but Vrms into Irms into cos phi r. So from this we need to find the value of IR. So for that VR you know, P you know. Okay, IR you need to calculate and cos phi r you know. So to find the cos phi r, we'll take the formula for tan phi r. So tan phi r is nothing but it is the reactive power divided by active power. So 800 VR divided by 200. From this you will get the phi r value. So phi r value it has 53.130. Okay. Now this phi r substitute here. So P is equal to VR into IR into cos of 53.13, and VR you know what is the VR 200. Okay, so P you know how much it is. It is 600, sorry, 600 here, also 600, sorry. Okay, now from this 600 is equal to 200 into IR into cos phi r value. So this value will be 0.6 here. So from this IR value going to as 5 amperes. So answer will be 5 amperes here. Next one. In a series RLC circuit, the power factor at the lower half power frequencies. So in my previous video, I discussed one question, similar second question there, but I made a mistake there. That in a series RLC circuit, the impedance at the half power frequency is root 2 times that of R. Okay, so please make a correction in my previous video. And in this question here, in a series RLC circuit, the power factor at the half power lower half power frequency is, so it is 0.707 leading here. So answer will be D. Okay, answer is D here. Next question. In a two element series circuit, the applied voltage and the resulting currents are respectively V of t is equal to 50 plus 50 sine 5 into 103 into t volts, and I of t is equal to 11.2 into sine into 5 into 103 t plus 63.4 degrees here. The nature of the element here it is, if you are taking the voltage as a reference, why? Because the angle is 0 and the current, sorry, it's not a 0 voltage here, and if you see the current here, current leads the element by 63.4 degrees here. That means current leads the voltage. So here current leads V. So what is the nature of the element? Nature of the element will be C here. Okay, if it's exactly 90 degrees means it's a C, but here it is 63.4 means it's a combination of RC network. So answer will be B here. Next one. A balanced star-connected load with the impedance of 20 ohms is connected across three-phase 4-wire 173 volt system with a voltage to neutral as 100 at angle minus 90, 100 at angle 30, and 100 at angle 150. The current in the neutral wire will be, so current in the neutral wire will be 0 when there is a system is a balanced system. So the question itself says that balanced means that the neutral current will be 0 here. So answer will be 0. Okay, if you want you can cross check by using the mathematical equations. In is equal to V by R formula. So 100 at angle minus 90 divided by 20 plus 100 at angle 30 divided by 20 plus 100 at angle 150 divided by 20. If you are doing like that, you will get answer as a 0 there. Okay, next question we'll talk about here. So yeah, this question. The voltage across a capacitor during the steady state. So we know that the voltage across a capacitor, so voltage across a capacitor is during the steady state means that the capacitor act as a open circuit. So whatever the applied voltage we are applying, 12 volts here plus or minus 12 volts here, the same voltage will be appearing across the capacitor here. So we see it becomes what, 12 volts here, open circuited, no current will flow. Next one, the BH curve is a the BH curve for dash will be a straight line passing through the origin. Okay, so here the options are given. The BH curve, so let me take H here and B here. Magnetic flux density, magnetic flux intensity. The curve is a linear, that means a no saturation. So no saturation means it's a air only. Okay, so air core coil will have a no saturation, right? Next one. So simple network here for the circuit, for the linear circuit shown in the figure. When R is equal to infinity, V is equal to 20 volts, R is equal to 0, I is equal to 4 amps, R is equal to 5, I is equal to dash. Okay, so I'll give a question mark for you. So try to solve the answer and tell me the answer for this question in the comment box. So comment in the, okay, so answer I will tell you later. Okay, now next question. So this question I have collected from the TNEB examination when the port 1 of n 2-port network shown the circuited, okay, short circuited here, short circuited, I1 is equal to 4 into I2, V2 is equal to 0.25 into I2, which of the following is true. So I discussed this question in my TNEB video. Okay, you can go through that video and you can judge the answer. The answer is for this question is, so Y12 is 16. Okay, so Y12 is 16 here. Okay, right. Next question. So sorry for the presentation. All right. A single phase transformer has a resistance and reactance of 0.2 per unit and 0.6 per unit respectively. Its per unit voltage regulation at 0.8 power factor lagging will be. So here we need to find the per unit voltage regulation. So voltage regulation per unit, okay, is equal to the formula here. It is the percentage resistance into cos phi r, okay, so plus or minus percentage x into sine phi r. So this is the formula here, the power factor is 0.8. So when the power factor is 0.8, if you're taking converting into sine it is going to be 0.6, right? Percentage resistance is what, 0.2 into 0.8 plus or minus. So they are asking for lagging, so lagging means automatically there will be plus sign here. Okay, so here we have plus, and then next, so let me make some thickness here, right? And x value will be what, x value will be 0.6 into 0.6. okay, so once you get the calculation here, it will get answer as 0.52 per unit. Answer will be a here. Okay, next one of the standard question in the transformers. The transformer has the maximum efficiency at 3/4 of its full load. The ratio of its iron losses and the full load copper losses will be. So X will be equal to full load kVA. So kVA full load into square root of PI by PC. Okay, so this full load means let us consider 1 here, and X is equal to square root of Pi by Pc. Now that implies x square is equal to Pi by Pc. What is the x value? Is nothing but 3 by 4. That is nothing but 3 by 4 whole square means 9 by 16. Answer will be C is the right answer. So this is one of the previous GENCO question. Next one, a 50 Hz 3-phase induction motor has a full load speed of 1440 rpm. The number of poles of the motor is, okay, so assuming that the full load speed is what, ns is equal to 1440 rpm, the slip will be around 4%. okay, like that, if you are taking, sorry, this will be nr, ns will be around more than that, so let's take a 15 rpm. okay, or otherwise you can go for the calculations of by taking this, assuming the slip is 4%, you will get the ns value. Now ns is equal to 120 f by p. okay, so p, right? Now 1500 is equal to 120 into 50 divided by, so P you need to calculate here. Okay, so if you are doing this, so the P will be, it is 4 here. Okay, so P will be 4 here is the right answer here. Next one, the ratio of starting torque to the normal torque in case of star delta starter will be, the ratio of the starting torque to the normal torque in case of star delta starter will be, it is 1 by 3 times. Answer will be 1 by 3 here. Okay, in order to minimize the both fifth and seventh harmonics, the coil span must be, it must be 5 by 6 of the pole pitch here. So standard question here, 5 by 6th of the pole pitch here. Next one. Okay, right, next one, the harmonic component of the generated EMF will be more in case of in alternator with a dash pitched coil. So repeat the question, in case of the harmonic component of the one of harmonic component generated EMF will be more in alternator with dash pitched coil. It's a full pitched coil. To reduce the harmonics only, we are going for short pitched coil or fractional slot winding. Okay, next one, in a DC shunt motor, the torque is developed is 15 Newton meter at 10 amperes of load current. If the load current is doubled, the new torque will be. So simply here in the DC shunt motor, the torque is proportional to Ia only, right? Now, so T2 by T1 is equal to Ia2 by Ia1, right? Ia1 here. Let me erase this one here. Maybe pen is not right. Now, Ia1 here. So from this T2 will be, so T1 into what is the Ia2, the current is doubled, so that means 2 into Ia1 divided by Ia1. So simply T2 will get, so 2 times that of T1, so T1 will be 15, so 30 Newton meter. So answer will be 30 here. So answer will be 30. Next one, an 8 pole 250 volts wave wound DC generator has a 200 conductors. If the generator is to be lap wound, the number of conductors required here is. Okay, so the options are 800, 100, 3200, 1600 here. Okay, so here observe, in a 8 pole means general formula is Eg is proportional to 5ZNP by 60A. Okay, so Eg for a lap connected winding means it, when P is equal to A, that means it depends upon the size of the conductors only. But in a lap connected winding, sorry, it's a lap connected, when the wave connected winding, Eg is proportional to, if we take the proportional to N, okay, so P automatically by 2 here. Okay, so from this, Eg is proportional to, sorry, as Z also you can take Z by here. Eg is proportional to Z. Okay, and what about the number of poles here? 8. That means 8 by 2 means 4. That means 4 here. That means second case, okay, the Eg will be proportional to 4 times that of the conductors. So how many conductors are there? 200. So that is nothing but 4 into 200 is nothing but 800 connectors are required here. So answer will be A. Next one, the transfer function of a system is 1 by s plus 1 into s plus 2. The impulse response of the system is, okay, so the impulse response of the system is Laplace transformation of uh, inverse Laplace transformation of the transfer function here. Okay, so once you are doing the partial fraction, 1 by s plus 1, okay, let me take A by s plus 1 plus B by s plus 2 is equal to 1, and doing the partial fractions you'll get the answer. I mean A is equal to plus 1, B is equal to minus 1. So from that, again applying the inverse Laplace transformation, okay, inversion of 1 by s plus 1 minus 1 by s plus 2, then you can say that e power minus t minus e power minus 2t. Answer will be t here. Okay, I'm not going to discuss in detail each and every question, just I'm giving the hint. You can find all the questions in my previous videos here. Next one, so little bit the number of forward paths in a signal flow graph here. So signal flow graph here, observe here. So here the current direction, I mean the direction is upwards like this. Okay, and you can try here. Okay, the number of forward paths are 4 here. Number of forward paths are 4 for this question here. And next here, okay, the effect of adding poles and zeros can be determined quickly by which of the following methods? The effect of the adding of poles and zeros can easily be determined with the help of Bordeaux plot here. Next one, which of the following is the best method for determining the stability and the transient response of the system? They are nothing but root locus here. Okay. Next one, a state equation of a system is x dash bar is equal to, I mean, x dot bar is equal to a bar x bar plus p bar u, where a is equal to a matrix 1 0 0 1. The state transition matrix will be, the state transition matrix will be for this question, it is a D, that is e power t 0 t into e power t into e power t here. Okay. Next one, a type 2 system has zero steady state error for a ramp input, parabolic input, step only, both A and B. So answer is, observe this answer here. So the given, actually the answer will be for the step and ramp. Okay, but the option here is only step only, they said. So only is the word that difference here. Okay, if the answer is ramp input, C step input means you can say D both A and B. But here only step only is given, so answer will be A only. So a little bit tricky question here. Next one, the characteristic equation of a second order system is s square plus 6s plus 9. The system is a dash damper system. So by looking the question itself, we can say by comparing the standard equation, s square plus 2 zeta omega n plus omega n square is equal to 0. By looking itself, omega is nothing but 3. Okay, omega is nothing but 3. Okay, let me correct here. 3. Okay. Now 2 zeta, here forgot about, yes, 2 zeta omega n is nothing but 6. So zeta is equal to 1 here. So answer is critically damped system here. Next question here, the number of roots of the characteristic equation s power 4 plus 4s cube plus s square plus 8s plus 1, that is on the right half of the lie on the right side of the s plane. I'll repeat the question here, the number of the roots of the characteristic equation s power 4 plus 4s cube plus s square plus 8s plus 1 lie on the right side of the s plane here. Okay, so how many in the RS criteria, so how many rows you are finding negative sign here? So that here answer will be 2 here. Okay, next one, the 230 volt bar 2300 star delta 3 phase transformer is rated at 230 volts kVA. Its rated secondary current per phase will be, okay, so first what you will do is they given star to delta, no? So let me take the power on the secondary side. How much kVA they given? So 230 into 10 power 3, let me take here, so 230 is equal to, I mean 230 into 10 power 3 is equal to root 3 times that of VL into IL. Okay, so from this IL you can get it as IL is equal to 230 into 10 power 3 divided by, okay, root 3 into VL value is 2300. So simply it is going to be 100 divided by root 3. But what the current has asked, the rated secondary current per phase is not a line. So IPH we need to calculate. IPH is equal to IL by root 3. Okay, so based on this I'll get 100 by 3, 33.33 amps is the answer. So answer will be A here. Okay, so next question, a single phase transformer, the copper losses at a full load is 600 watts. At half of the full load the copper losses will be dash watts. Okay, so full load IFL Okay, so copper losses means we can say uh, IFL at full load. Okay, so full load WC. Okay, WCFL is equal to 600 into x square. So let's say x is full load means x full load means x is equal to 1. Now WCFL at what load? Half of the full load means 1 by 2 whole square into 600. So it is 150 watts here. So answer will be D here. And the last question of the session, because our time has reached almost 20 minutes. One of the speeds of a two-speed squirrel cage induction motor is 600 rpm lower speed. The other speed will be. So other speed means it has a two speeds. As I mentioned that the value will be lower speed. Okay. What about the highest speed means so multiples of this 600 here. Okay, multiple of 600 means the next speed will be the second level. That means almost double speed. So double speed means 600 into 2 is nothing but 1200 rpm. So D will be the answer. Okay, so we'll continue the remaining questions in the upcoming sessions. Okay, thanks for watching my video. So thanks for watching the video without skipping here. And don't forget to press the bell icon button so that you can get the daily notifications of my videos. Have a nice day. Hi, hello friends. Welcome to T Academy. Let's continue the series of AP assistant engineer electrical questions here. So I have collected the questions from the various examinations of AE standard paper. So let's continue the series of questions here. In my previous video, we discussed up to 27 question. Now let's start from the 28th question here. And my request is to please subscribe to the channel and press the bell icon button so that you can get the daily notification of my videos. And please watch the video till the end. Don't skip the video if you know the question and answer here. Okay. So this is useful for you as a part of your preparation for AE examination. Now let's start the questions here. A question is a synchronous machine has excess is 1 per unit and operates at V is equal to 1 per unit. The EMF is at 1.5 per unit and the load angle, current as 0.5 and the 0 plus j 0.5 and the mode of operation here it is. Here the examination is asked you to find the what is the condition of the machine, whether it's working as a generator or it as a motor, and what about the power factor here. So here first what we'll do is we'll take the uh, current. So current is a j 0.5 means it's a leading. Okay, the current is leading here. Okay, now whether we need to check is a machine is working as generator or a voltage, but by looking at the question itself we can say EMF is 1.5 per unit and voltage is 1 per unit. You can say that the machine is a generator and it's leading power factor. So that's wrong here. Actual thing is here, just check the voltages and currents here. So let me take here, if I tell the formula V is equal to E plus, okay, IA into ZA here. Now what is the value of V? V is nothing but E is nothing but 1.5 and IA. So IA is nothing but J 0.5 E into the ZA value is 1 per unit. Okay, so that is J1 here. Okay, the notation you have to consider. Then 1.5 j into j means j square. J square means nothing but minus 1 into 0.5. That means V is 1 per unit. That means the condition is satisfied here that the voltage is 1 per unit and EMF is 1.5 per unit. But what about this condition here? So V is greater than E. So this is happens only in case of motor. Okay, that means the machine acting as a motor with a leading power factor. So answer will be C here. Next question. Yeah, next question is the armature winding of an alternator. The coil span falls short of full pitch by 60 degrees. The pitch factor is. The pitch factor Kp is nothing but cos of alpha by 2. So alpha is what is given as 60 degrees here. There's nothing but cos 30 degrees here. So this is nothing but 0.866, or we can also add as root 3 by 2. So here alpha is 60 degrees in the given question, right? So answer will be B here. Next one. if the flux per pole of a DC generator halved but its speed is doubled, its generated EMF will be. So we know the basic formula Eg is proportional to 5 ZNP by 60 into A, right? In this question, the flux per pole of a DC generator is halved. That means Eg is proportional to 5 into N here. What the thing that it is, Eg is proportional to flux is become halved, means flux divided by 2 into the speed is doubled. That means N into 2. So gets cancelled means Eg remains as 5 into N only. So remaining, okay. So they remain same. The new generated EMF will be remain same. Why? Because the flux, you are increasing the flux at the same time. Sorry, you are decreasing the flux at the same time you are increasing the speed. Okay, so both are proportional here. Now, which type of motor is most suited for the computer printer drives? So best option is D, stepper motor. So stepper motors are used in typewriters, line printers, XY plotters, and floppy disk drives and tape drives here. So answer is D here. Okay. Next one. 32nd question. In a torque slip characteristics of a three-phase squirrel cage induction motor, the torque will be maximum. Okay, I'll repeat the question. In a torque slip characteristics of a three-phase squirrel cage induction motor, the torque will be maximum when, so it is the torque equation dt, there is a differentiate with respect to variable s is equal to 0 here. So answer is dt by ds is 0. Next question here, right? So simple question. In a balanced three-phase system, negative and zero sequence currents are, okay. So what are the currents? So they are equal, they are zero, they are different, they are one. Okay. So in a balanced system, the negative sequence and zero sequence currents are zero, they are absent. Okay. So they are present only in case of a unbalanced system only. Balanced system only positive sequence will exist. Next one. The value of a transmission line impedance is a 5 per unit with a 10 MVA 10 kV base values. Its impedance in ohms here. Okay, so its impedance is in ohms. You need to calculate here. So how you are going to do is, the first formula is, that is Z per unit. Standard question for electrical engineering paper. Okay, Z per unit is what? Z actual value by Z base value. What is the Z base value? Z base value is nothing but, okay, so it is V base square divided by S base here. So VB square means here, what is the base value? 10k whole square divided by S base is 10 MVA. Okay, so k square means 100 divided by 10, like that you will get it. Okay, so it's nothing but 10 here. Now what is the value of ZA? Z actual value is in ohms is equal to Z per unit is 5 into ZB value. So into ZB. So what is Z base value? 5 into 10, 50 ohms. So these kind of questions are asked frequently in AE examinations, right? Especially in case of Telugu states examinations. So this is a standard question. So based on this formula, you'll get questions here. Okay. So please be aware of these two formulas here. They are very, very important. And definitely there will be one question in the per unit system. Next one. The ratio of full load volt amperes to short circuit volt amperes is equal to, the options are short circuit MVA to base MVA, Z phase, V phase, short circuit current. So answer is Z phase. So Z phase is nothing but full load volt amperes to the short circuit volt amperes. Okay. Next, let's move to the question number 36 here. All right. Now here, for a 20 bus power system with one voltage controlled bus, the size of the Jacobian matrix is, okay. So here there is only one controlled bus. The formula is 2n minus 2 here. Okay, what is the n? N is nothing but 20 bus system, so 2 into 20 minus 2 here. Okay, so that is a 38 cross 38. So answer will be A here. Okay, next one. Sorry, the coefficient of reflection for the current wave when it is open circuited. The option given is open circuited. So when it is open circuited, the current, the reflection coefficient is -1 here. When it's a short circuited, that is +1. Open circuited, -1 here. Okay, and let's move to the next question here. Right. So between the two supports, due to the sag, the conductor takes the shape of. So said, let's take here. There is a one conductor. There is a one pole here. Let me take another pole here. Somewhere it is, and the conductor between these two poles will be like this. So this will take the shape of catenary. Okay, so catenary shape. So important one. Next one. For a 500 Hz frequency excitation, a 50 km short power line will be modeled as. So as the frequency is high, okay, the line is modeled as long transmission line. Answer is C, long transmission line. Next one. So this question is from the power electronics, right? A 200 volts DC to DC converter is turned on for 30 microseconds and turned off for 10 microseconds. Let me correct here. So 10 microseconds, the output voltage will be. So here in the question, the examiner didn't specify the output. That means what type of converter it is. So there are two options here we have. One is a step up, second one is step down. Now you have to judge the type of converter by looking the answer here. So see here, the question itself saying that there is a 200 volts DC to DC converter or chopper. Input is 200 volts. See the output voltage what they are given. So 200, 150, 175, 120. That means output V0 is less than that V's supply voltage. That means what type of converter it is? Yes, it is step down converter. So depends upon this concept, you need to judge the answer. Now we need to find the value of delta. So delta is nothing but T on by T on plus T off, right? Now what is the T on? So on for 30 microseconds. 30 microseconds divided by T on plus T off means 30 plus 10 microseconds. So it's nothing but 3 by 4, you get it, right? Now V naught is nothing but Vs into delta. There's a formula for step down converter. So V naught is equal to, what's the Vs? 200 into 3 divided by 4. Okay, so it is nothing but 150 volts. So answer will be B is the right answer. So output voltage will be what? 150 volts here. It is nothing but a step down chopper here. Now next one. This question I have collected from the power electronics, and the concept is inverters. The fundamental component of single phase FBI means full bridge inverter. So expansion right here, full bridge inverter. So output voltage is, the fundamental component means where the fundamental components and the other harmonics is n is equal to 1. So among the options here, B is the right option. So 4 Vs by n pi into sin omega t, when n is equal to 1, nothing but 4 Vs by pi into sin omega t. So this is the fundamental output voltage of a full bridge inverter. Okay. Next one here. So interesting question here. A converter is feeding a DC machine as shown. The mode of operation here it is. So here they given simply a chopper here. So chopper here. But observe the current directions. The current is a reverse direction. Okay, the current is in reverse direction here like this, and the EMF in the same direction. Okay, so both are in the same direction here it means. And see here that we have reversed the voltage. That means we are going to reverse the voltage in case of plugging operation only. In plugging operation, what we'll do is we'll first run the machine as a motor, and by changing the terminals of the motor, then the motor it acts as a generator. That means we'll generate opposite torque, okay, by using the plugging concept. So in this plugging concept, the current is very high. Okay, the basic formula is I is equal to V by V plus EB by R here. So this is a basic concept here in case of a plugging. Okay, so in the plugging, the voltage and the EMF of EV both are in same direction. Remember this point here. So V and EB, they are opposing, supporting each other. In normal mode of operation, they are opposing each other, but in case of plugging mode of operation, both are in same, that is additive direction here. Next one, it is required to construct a counter to count up to 100 decimal. Okay, doesn't consider say a binary value. The minimum number of flip-flops required to construct the counter it is. Okay, how many number of decimals we need to count? 1 0 0, that means 100. Okay, so with the flip-flop we can count two numbers, that is 0 or 1. Like that, if you are going, then you have to consider 2 power n. So 2 power 7 is going to be, so 2 power 7 is going to be count 128. Okay, so 2 power 6 means it is only 64. So 2 power 7 means we need a 7 flip-flops as a minimum number required to construct the counter here. So answer will be 7 here. Okay, this question I have collected from Odisha Polytechnic examination paper, right? Next question. The simplest equation which implements K-map shown in the figure. So they given a K-map here. In this K-map, you need to calculate what will be the equation here. So let me take the equation will be F. Okay, answers are there. So first I will combine these four combinations here as it is. See here, what is the common point here? B. And this is there any common point here? No. So answer first I'll get it as a B. Okay. Next I'll observe here. See there are. I'll map these 2 points. Once I will map these 2 points, what you'll get here is common point here it is C. Here it is A. Okay. A, B plus A. And C here, is there any common point here? C. C. That means AC plus B will be the answer for this question here. So answer is A here. Next one. Right. Next question here it is digital electronics. How many 3-line to 8-line decoders are required for one of 32 decoders? Okay. See here, if you are taking the output here, we need to have 8-line decoders. Okay, 8-line decoders are required for 32. That means the output one decoder will give a output of 8 lines. But how much I want? I want 32. Okay, so if I get a 4 8-line decoders, then I will get 32. Okay, so that is the answer here. So answer is 4. Next one, convert BCD 0001 0010 01110 to binary here. So this is a binary code here. First what we will do is we'll convert this values into its equal decimal value. That is 001 is 1 and this will be 2 and here it will be 6. Now 1 2 6 I'll multiply, I'll divide it 2 here. So 2 63 remainder 0. So 2 31 remainder will be 1 and 2 here 15 remainder will be 1 and 2 7 14 remainder will be 1. So 2 3 6 remainder will be 1 and like that if you are doing, then again you will have, okay, again you will have 2, okay, 1 dash 1 here. Okay, so if you are going in this manner here, so the code will be 1 1 1 1 1 2 3 4 5 6 7. Okay, the answer will be 1 1 1 1. Okay, and 1 1 0. See here 1 2 3 4 5 6. So 6 0. But in the given options there are 8 codes here, 8 bits are there. So 8-bit code is a there. Here we question is 7-bit. Answer is 7-bit here. So answer will be what? None of the above. So for this question, no answer is available here. Exact answer will be 11111110. So okay. So if you are erasing this part, then this will be the correct answer for this question here. Okay, so let's move to the next question. An amplifier without feedback has a gain of 1000, the gain with a negative feedback of 0.09. So gain with the feedback is nothing but gain without feedback divided by 1 plus E into beta. So A value is what? 1000 divided by 1 plus 1000 into 0.009. So that will be equal to 1000 divided by, okay, so 0.00 means multiply with 1000 means it will going to be 9 plus 1 10. So it is 100. So answer will be here. So what you can observe here it is in the amplifier without feedback means what type of feedback you are considering here. So we are considering negative feedback. Okay, from the negative feedback what you can observe, when the amplifier without feedback has a gain of 1000, but same amplifier with a negative feedback it has a 100. That means what we can say, by using the negative feedback the amplifier gain is going to be decreases. That is a conclusion point from this question here. Next one. In the differential voltage gain and the common mode voltage gain of a differential amplifier is 48 dB and 2 dB respectively. The CMRR is, so CMRR is nothing but the difference between differential gain by common mode gain. But in case of dBs means it is, okay, so 20 log. Okay, so we'll write down 20 log here. But the other given questions are in the log only. So directly AD in a dB minus AC in dB. Okay, that's nothing but a 48 minus 2 is nothing but 46 dB will be the answer. So given data in the dB, so that's why we'll differentiate directly. So answer will be 48 dB. Sorry, 46 dB. 46 dB here. Next one. The mobility of electrons in a material is expressed in units of, so units of meter square by volt seconds here. Okay. Next one. Oscillators uses dash feedback. So oscillators uses positive feedback where the gain is increases and the remaining things are going to be decreases in case of this oscillators here. Okay friends, thanks for watching my video. If you like the video, please subscribe to my channel and press the bell icon button and share with your friends, and don't forget to share with your friends here. Have a nice day. We'll continue the next uh, series of questions for assistant engineer electrical. Please support us.